we call the definite integral is the net area, right? Net area under the graph or between the graph, which is the graph of the function f of x or the y and the x-axis. For the left graph, the function is 2 times 2x plus 4, which is the equation of the line, or 4x plus 2. The slope is 4. The intercept is 2. So that's the y-intercept 0b. With the slope 4, go up 4 unit, go over 1. So 1, 1, 2, 3, 4, and then go over 1. So up 4 over 1 to get the next point and do the same way. That's the general way to sketch the graph of the line, the y equals mx plus b. The geometry of this substitution, when you find the definite integral of 2 times 2x plus 1, that means you find the area from point A to point B. Point A is 0, point B is 2. The area between the line and the x-axis. If you treat this as a function that you can use the u substitution, let u be, let's see, the 2x plus 1 for this problem. If we let u be 2x plus 1, what is differential u? Differential u is the derivative multiplied by dx. Derivative of 2x plus 1 is 2. And if you manage this, the integral from 0 to 2, the quantity 2x plus 1 multiplied by 2 times dx, when you replace it totally in the u form, the portion 2x plus 1 is the u, the 2 times dx is the du. Okay. Again, lower limit, upper limit, 0 and 2 are x value. That means for x equals 0, the u is 2 times 0 plus 1, which is 1. For x equals 2, the u is 2 times 2 plus 1, which is 5. Now the new lower limit, upper limit will be 1 and 5. Integrand u with respect to u. That's definite integral on the right graph there. So the integral from 1 to 5 of the function u with respect to u show you the area or the net area under the line y equals u. The lower limit 1, upper limit 5. This area R prime is the same quantity as the area R on the left hand side. So this is the explanation using the geometric version. Okay. All right. So for the example, we're going to find the area of the following regions. I put 2 examples for this part of the package. The function that we have, y equals secant square of x over 2. And the region bounded by this graph and the x-axis between x equals pi over 2 and x equals 2 pi over 3. Or we can see this is the left end, or this is A, and the 2 pi over 3 is the B. We're going to find the area or the definite integral from pi over 2 to 2 pi over 3 of the function, which is the secant squared of pi over 2 with respect to x. That's a setup. Okay. You can verify with the graph, and the graph supposed to be greater than 0 in order to do this way. Otherwise, it's gonna represent like just the net area. That's the negative area, positive area adjust to each other. So the area is set up to be the definite integral in this form. Secant square as a function, secant square of pi over 2. No, this is not pi over 2, sorry, I'm wrong. So it's secant square of x over 2. Miscopy. So secant square of x over 2. Secant square of something. So that's indication of the composite function, and the of something that means of the inner function. So that's the inner function. Then it will help you set up the new variable u as x over 2. Next part, what is differential u? Differential u is the derivative multiplied by dx. Derivative of x over 2 is 1 over 2 or a half. And write it as dx equals, you treat them as you multiply both sides by 2 to solve for dx. So dx is 2 times du. We're going to work on replacing terms. Okay, I'm going to leave lower limit, upper limit as the empty spot right now. Work on the main part. The main part, the integrand is secant square of the new variable u. The dx is now 2 times du. Okay, the inside of the integral sign, everything is in form of the u. I'm going to work on changing the lower limit, upper limit on the prep work, on the side work here. For the x, lower limit x equals pi over 2, the u, which is x over 2, I can write it as 1 half times x, right? So going to be 1 half times pi over 2. That gives me pi over 4 as the lower limit in form of u. Upper limit x equals 2 pi over 3. U is 1 half of the x quantity, or the 2 pi over 3. 2 and 2 reduce. My upper limit is pi over 3 now. So u equals pi over 3. Okay. So then we have everything totally in form of the u. Upper limit, lower limit, already change it into the u variable. Okay, add more working area. We'll go back to this problem real quick. So we have integral from pi over 4 to pi over 3, secant square u to du. Or we can write it as the coefficient 2 here outside the integral sign, pi over 4 to pi over 3 of secant square of the u with respect to u. Okay, everything changed completely into the u form. So so the area is 2 integral. I just copy from the previous slide. Oh, this is u, sorry, and du. Okay, the next part, think about the antiderivative of secant square u, or what function that its derivative is secant square. On a side note here, if you have the formula card, that's great. So you can look it up and see what's going on. So the derivative of the tangent is secant square. This is variable u, so apply to the same. Now, the antiderivative part is tangent of the variable u. Okay, integral sign and du gone. We're gonna work on replacing lower limit, upper limit. Lower limit pi over 4, upper limit pi over 3. Upper limit first, so the tangent of pi over 3 minus lower limit tangent of pi over 4. As you see the pattern of the problem for the definite integral, after you change it completely into the u form at this step, we don't look back at the x term. We just keep going, working on finishing up problem involving u. So no x involved. Okay, no x involved after this point. Now we can calculate the tangent of pi over 4, which is a tangent of 45 degrees, is 1. The tangent of pi over 3, or the tangent of 60 degrees, is square root 3. Okay, now the answer is 2 times square root 3 minus 1 as the exact solution. So this represents the area between the graph of y equals secant square of x over 2 and the x-axis between pi over 2 and 2 pi over 3. Okay. Yep. And another example. Same situation for the area of the region bounded by the function y equals x over square root x squared minus 9 and the x-axis between x equals 4 and x equals 5. Set up the definite integral or the area as a definite integral from the lower limit 4 to upper limit 5. Everything in the x form at this point. So x over square root of x squared minus 9 with respect to x. What should be the variable u for this problem? The one that looks the most complicated, right? The x squared minus 9 as the inner part of that complicated form. So the u is x squared minus 9 followed by differential u, which is the derivative multiplied by dx. Derivative of x squared minus 9 is 2x. And then work on this as solving for dx. dx is du divided by 2x. We're going to bring it back into the problem and simplify one at a time. If you untangle it, this is 1 over square root of x squared minus 9 multiplied by x dx from 4 to 5. Recall 4 and 5, they are x value. Replace one at a time. The square root of x squared minus 9 is 1 over square root of u. The dx is du divided by 2x. Simplify x and x cancel. Right now we see everything in terms of u. One more thing that we have to do before we find antiderivative is changing the x into the u values for the lower limit, upper limit. Still on the prep work, see you work like side by side and go back and forth to get everything replaced into the original expression and then it's totally in form of the u. As x equals 4, u is 4 squared minus 9, which is 16 minus 9 and returns what? 7. Okay, 7. For x equals 5, u equals 5 squared minus 9 or 25 minus 9 or 16. Okay, 16. Lower limit for the u is 7. Upper limit is 16. Clean up to get ready to find the antiderivative. Now we have the integral from 7 to 16. The coefficient, as after we reduce x and x, we still have the 2 here on the bottom. We're going to factor it out as a coefficient. So going to be 1/2 the integral from 7 to 16 of 1 over square root u with respect to u. It's less, it's simplified much more than the original one and it's much cleaner and everything is in terms of u that you can see. You can use the basic antiderivative to apply to this problem and get the answer out. At this step, again, no x involved. Everything just target only the u form. Next part, find the antiderivative of 1 over square root u. Recall the square root u is u to the power 1/2. Okay, when you do 1 over square root u, that is 1 over u to the power 1/2. Write it as a power. That means the power becomes negative inside. Then the integrand that we work on is u to the power negative 1/2 with respect to u. This form is easier to see that the power rule will be applied, the antiderivative of the power rule, which u to the negative 1/2 plus 1 more to get 1 over 2. Okay, from the antiderivative of u to the power n, which is u to the n plus 1 divided by n plus 1. And then you can add c for the indefinite integer. For this case, we ignore the c. So add 1 to the negative 1 half becomes 1 half. And the new power is used for the denominator. When you divide, it's the same as multiply by the reciprocal. So gonna multiply by the reciprocal of 1 half, which is 2 over 1. Okay, and then we're gonna evaluate from u equals 7 to u equals 16. Simplify. See, almost every single step, we're gonna simplify, simplify, simplify. Problem gets less complicated every time that you simplify it. So 2 and 2 reduce. The u to the 1 half is square root u. What we gonna work on? Replace 7 and replace 16 and subtract them. Now we have square root 16 minus square root 7. We have square root 16. We can simplify to be 4. So the final answer is 4 minus square root 7